It has been some time since we originally built this Z180 system. This system exhibited some problems when I tried to initially power it up. So I put it aside and decided to have a look at it later. As part of my investigations, I of course checked all the solder joints, assuming that it was one of those that was actually the problem. However, it turned out I'd made a fairly basic mistake. Of the 3 large chips in the memory board, I'd in fact inserted 2 of them the wrong way round. A fairly basic mistake, which I'm always advising people to check, and I'd actually managed to miss it myself. So now we have a working Z180 processor computer. As you will see from the backplane, we have 4 slots still unoccupied, so this particular computer is capable of considerable expansion. So what I'll be doing today is actually testing out the main processor board and the memory board by connecting it via serial cable to my computer. The power requirements of this particular board are quite modest. The power is supplied through this barrel jack, and I'm going to be driving this system with a power pack. And this is a power pack I'm going to be using. So we merely have to connect this via a USB to barrel jack connector. And that is our power connected. There is a power on-off switch at this side, which if we switch on, we will see the LED light is now illuminated. So the unit is now ready for operation. So let's connect it to our computer. I'm going to be using one of these standard cables to connect the top slot to the computer via the USB plug. And we're going to be connecting to this using TerraTerm. So let's switch to the view from the main computer to see what it's going to look like when it boots up. So now that we have our little Z180 computer plugged in to our main computer, we can now launch TerraTerm. And we're going to be connecting by serial. And the port we're connecting to in this case is COM3. Depending on your computer settings, it may not be COM3 on your machine. So once we've okayed that, we now have to go into the setup menu and set the serial port settings. And we're going to increase the speed to 115/200 and just click New Setting. Next, we're going to change the font to make it a little easier for you to see, and we'll make this up to 18 point. With that done, all we need now do is to press the reset button on the backplane. And there we have it. The computer has now powered up, and we're now sitting in the bootloader. As you can see from the list, there are 2 settings already populated. We have a RAM disk set up and a ROM disk. The ROM disk is where all the programs down here are going to be coming from, for example CPM, BASIC and Forth. So on the options on ROM, we can go first of all to the monitor. Hit the H for help, and we can see what the monitor actually does. On the monitor commands, one of the options we have is to dump memory. That is, display the memory on the screen. So we have now displayed the locations 8000 or 8000 up to 8020. These of course are hex values, as in hexadecimal, base 16. So if we press B to boot the system, it would take us back to the screen we were on before. Let's next have a look at CPM. This is telling us we have 2 configured drives, an A drive and a B drive. If you've never used CPM before, many of the commands will be familiar from DOS or the console window in Windows. dir will list all the files on that drive. CPM doesn't have the concept of folders, so you don't have any folders to look at on your drive, just files. Amongst all the utilities you get with CPM, you'll see there was a file on here called mbasic. This is Microsoft Basic, which will allow you to write a program, which you can then list. And if we run the program, it will display what we've asked it to display, the first 10 numbers. If we go back to CPM and have a look at the A drive, we'll see that the A drive currently has one file in it, text.txt. Let's create another file on this drive from within MBasic. Here is the program I used to create the text file. The first line is telling BASIC that we want to open a file for output. It's going to be the first opened file, and it's going to be on the A drive, and it's going to be to text.txt. So let's change that, and we'll make that text 2. And if we list our program now, we'll see it's now going to go create a new file. If we run that program now and exit back to CPM, go back to the A drive, we'll now see that there are now 2 files on that drive. However, it's worth remembering that this A drive is a RAM disk. Therefore, any files you save to this RAM disk will disappear as soon as you power the computer off. So if you wish any permanent storage on this particular computer system, we're going to have to add an external drive. There are a number of other options on this bootloader. We can go into the Z system, you can attempt to program in Forth, you can use another version of BASIC called NASCOM BASIC. NASCOM BASIC does have the advantage in that it gives you more memory to play with. This is because it's not running under CPM, and it will not save to any drives, but it will allow you to display more on the screen and to run larger programs. So I think so far we've proved that this CPM system is working nicely. The one advantage this system has over the previous systems we've reviewed is that the z180 processor is in fact much faster. It runs at a higher clock speed. Not only that, since it's a z180, it can address up to 1 megabyte of memory, which is considerably more than the 64 kilobytes the z180 processor can normally do. However, since we're using CPM on this computer, it does have the advantage that it can actually handle the memory in banks of 64K. So in future videos, we may actually add a compact flash module to the system to allow us to have permanent drive storage. However, that's it for today. Thank you for watching.